Okay, electronic configuration. Let's go. Explain which particle is a negative ion. Right. We've got these four particles here, W, X, Y, and Z. They have this many electrons, neutrons, and protons, and we have to explain which particle is a negative ion for 2 marks. Okay. If an ion or a particle has a negative charge, and therefore is an ion, if it is a negative ion, it must have more electrons than protons, because neutrons are neutral, they don't carry a charge. Okay? Electrons carry a -1 charge, a negative charge. Protons carry a +1 charge. So if you have more electrons than protons, you'll have an overall negative charge. So, explain which particle is a negative ion. Well, it's Z. Z is the negative ion because it has more electrons than protons. See, it's got 18 electrons and 16 protons. The others, that's got the same, that's got fewer electrons than protons, so that will have a positive charge. It will be a positive ion, X, and W and Y is the same, so they'll be neutral. They're not ions. An ion is a charged particle, whether it's positive or negative. Okay. In the exam, say as much as you can. You've got to get 2 marks here. Maybe you'll get 2 marks, maybe you won't, but if you say what the actual charge is, you'll definitely get the 2 marks, okay? If you just write Z down, you won't get the 2 marks. If you say that, you may get the 2 marks, but always, don't take a risk. Include the actual charge. So 18 minus 16, there are 2 extra electrons and protons, so it will have a 2 minus charge. Okay? Good, definitely got 2 marks. Right, next. Calcium nitrate. We have to calculate the relative molecular mass, or the relative formula mass, same thing, that's MR, of calcium nitrate. Okay? So, they tell you what the relative atomic masses of the individual atoms are. You write AR for individual atoms, relative atomic mass, and MR for a molecule. Okay? So, the AR of calcium is 40, nitrogen is 14, and oxygen is 16. So, the MR of calcium nitrate is equal to the AR of, how many calciums has it got? It's got 1 calcium. Okay, so just 1 times the AR of calcium, plus, how many nitrogens has it got? There's a little 2 outside the brackets, and there's 1 nitrogen inside the brackets, so we must have 2 nitrogens. So 2 times the AR of nitrogen, plus, how many oxygens has it got? There's 3 oxygens inside the bracket, and there's a 2 outside the bracket, so it's 3 times 2, we have 6 oxygens. So it's 6 times the AR of oxygen. Okay? So the MR of the whole thing is, AR of calcium is 40, 2 times the AR of nitrogen is 14, and 6 times the AR of oxygen is 16. So that's 40 plus 28 plus 96 is 68 plus 96 is 164. There we go. MR of calcium nitrate is 164. Good. Just briefly, if this NO3 in brackets with a little 2 outside confuses you, let me just clarify that and draw what that actually means. Okay, when you get this bracket thing here with little numbers inside, little numbers outside, I'll show you what it means. Let's have a change of colour. Why not? Let's do this in blue. So this is a bit of extra on top of the question, okay? We've done the question. Just want to make sure that this notation doesn't confuse you. So, calcium nitrate looks like this. You have a calcium atom in the middle. There's just one of them, okay? That 2 only applies to the brackets. It means there are 2 NO3s. So you've got calcium in the middle, and then you've got 2 NO3s. So one this side and one that side. Now NO3 looks like this. You have a nitrogen with 3 oxygens bonded to it like so, okay? And the nitrogen has a positive charge on it, and these 2 oxygens both have a negative charge. Okay, don't worry too much about this. It's just a bit of fun information. Then you've got the same thing on this side. You'll have an NO3 here, which looks like this. Okay, positive charge on the nitrogen, negative charge on those 2 oxygens. Okay, and the calcium in the middle will have a 2+ charge on it. So that is what calcium nitrate looks like drawn out in more detail. That and that are the same thing, okay? So that's what they're representing with these brackets and the little 2. It means there are 2 NO3s. So here's one NO3 there, and there's the other NO3. See, in each NO3, in each nitrate, there's 1 nitrogen and 3 oxygens. NO3. One of them there. NO3. Another of them there. So that's NO3, brackets, 2. Okay? The little 3 refers to the 3 oxygens inside each NO3. There's 1 nitrogen and 3 oxygens. 1 nitrogen and 3 oxygens. And there's 2 of those. 1 there and 1 there. And 1 calcium. Okay? Now, for GCSE, you don't worry about this. You don't need to be able to draw it out. But if you can, it definitely helps. And it helps to see it, I think, to understand what this actually looks like. And don't worry about the charges too much either. That's just what a nitrate looks like. It just so happens that there's actually 4 bonds on the nitrogen. Nitrogen normally has 3 bonds, but it can form 4, and in this case it does. There's a positive charge on the nitrogen and 2 negative charges. So 1 positive, 2 negative charges. Overall, it's got a -1 charge. So there's an overall -1 charge there, an overall -1 charge there, and a 2+ on the calcium. So overall, it's got no charge. But it's an ionic compound because the calcium has a charge and these 2 both have a charge. Good. Let's move on. All right. So, right, we're now on to lithium fluoride. Okay? And they tell you it's ionic. Yes, it is. Now, the first thing they show us is 2 atoms. 1 atom of lithium and 1 atom of fluorine, and they show you the electronic structure, okay? And we have to draw the atomic structure of lithium fluoride. I think that's it for the whole question. Yeah? No? Okay, great. Now, very important to realise that the drawing they give you on top, these are both individual atoms. They are not chemically bonded in any way, okay? I know they've drawn them the same distance apart as the lithium fluoride underneath that we're going to draw here on the question sheet. But let's be very clear. These are 2 individual atoms and they are not connected, okay, in the top diagram. Because the lithium has 3 electrons, so it's uncharged, and the fluorine has 9 electrons, so it is uncharged. You see, fluorine has 9 protons. So in fact, W there, because it's got 9 protons, that would be a fluorine. Okay? So, right, we just have to draw lithium fluoride. Okay, no problem. So it's an ionic compound. Oh, the other thing, I know they drew the lithium electrons with crosses, but I'm going to do them as dots and crosses, okay? Because it's better, right? You won't lose marks for doing this in the exam. I encourage you to do dot and cross diagrams because it shows which electrons came from the lithium originally, which came from the fluorine. Okay, so the inner shell is unaffected. It will still have 2 electrons on it like that. Oh yes, and the other thing, you notice I've drawn the electrons in pairs on the fluorine. It's a better way to do it, okay? Even though they've drawn them sort of all evenly spaced. Right. Okay, same with the fluorine. The fluorine, the inner shell will be unaffected. Okay. Now, what's going to go on in the outer shell? Well, quite simply, this electron from the lithium is nicked by the fluorine and it ends up next to that electron there. Okay? So the fluorine gets a full outer shell of 8 and the lithium gets a full outer shell. You see, the new outer shell for the lithium is this one with 2 electrons. So they both get an outer shell, which is what they want, if you like. They're more stable in that condition, which is why, see, it's why lithium fluoride is why they go well together. When atoms get full outer shells, they're happy and stable. So that's why this is a good marriage, and you find lithium fluoride in nature. Okay. So that electron has gone over here. So that's it. It's now got an empty shell. That shell is now empty. And it's gone to there. And the other electrons remain in the same position. Okay? So that's what happens to the electrons. That one has moved over there. Both got a full outer shell. But we're not finished because we have to show the charges on these two. Okay? When you're doing a dot and cross diagram and you're dealing with an ionic compound, which this is, you have to show the charge on the ions. And you do that with square brackets. So don't forget to put square brackets around these two ions, okay? And you write the charge here. Now, lithium has gone from being uncharged, 3 protons, 3 electrons, to 3 protons, 2 electrons. Okay, so that's +3, -2. Overall, it's got a +1 charge. Okay? You can just write plus if you want, but I write +1, either is fine. Okay? Now fluorine has gone from being neutral, 9 protons, 9 electrons. It's now got 9 protons, 10 electrons. Electrons have a -1 charge, so it's now got a -1 charge on it. Okay? And the last thing I want to say with ionic dot and cross diagrams is, you notice I didn't overlap the outer shell, okay? You overlap them with covalent dot and cross diagrams. This is not a covalent compound, it's an ionic compound. Because these two have a charge, it's ionic. With ionic compounds, ionic bonding, you don't draw the shells overlapping. You draw them, you see there's a gap there. Space for you to put the square brackets in, okay? Yes, good. And that is how you should do ionic dot and cross diagrams, okay? Don't overlap the outer shells. Use dots for one of the atom's electrons and crosses for the other. Don't forget the square brackets and don't forget to put the charges in. And that's it. That is lithium fluoride. Okay? That is not lithium fluoride. That is an atom of lithium and an atom of fluorine. But that is lithium fluoride. And I think that concludes the question. Yes, it does. Not too bad, right?